Hello everyone, I Professor Sonavne SC from Civil Department in Structural Design and Drawing. Is the next problem is a RC beam section of size 230 mm wide and 430 effective depth is reinforced with 3 numbers of 916 mm diameter bars. Find the moment of resistance of section using WSM approach. Also find shape intensity of uniformly distributed load that can be placed on simply supported beam of effective span 4 meter. Use M20 grade of concrete and Fe 250 steel. Then solution is width 230 mm, effective depth D is equal to 430 mm. Then reinforcement 3 by 16 mm, effective span L is equal to 4 meter, M20 and Fe 250, sigma CBC 7 Newton per mm square and sigma ST 140 Newton per mm square. Then to find safe UDL WSM modular ratio M is equal to 283 sigma CBC is equal to the 283 into the 7 is the 13.33. This is M. Then area of steel in tension AST is equal to the N into pi by 4 d square is equal to the 3 into pi by 4 into 16 square. Step number first, critical depth of neutral axis XC is equal to the 1 upon 1 plus sigma ST M into sigma CBC D is equal to the 1 upon 1 plus sigma ST is the 140, modular ratio is the 13.33 into sigma CBC is the 7 into the D is the 430. Then calculate is equal to the 0.4 into 430, we get 172 mm. Then step number second, actual depth of neutral axis. Actual depth of neutral axis x, bx square by 2 is equal to the m into ast d minus x. 230 x square by 2 is equal to the 13.33 is the area of steel, 603.19. 430 minus x is equal to the 115 x square is equal to the 3.44 into the 10 raised to 6 minus 8000.5 x. Then 115 x square plus 8000.5 x minus 3.44 into 10 raised to 6 is equal to the 0. Then solving equation, we get x is equal to the 141.63 mm. Then step number 3, type of section. Since x is less than xc, the section is under reinforce. The section is under reinforce and beam fails in tension. Step number 4, moment of resistance. Mr is equal to the T into Z is equal to the sigma st ast in bracket d minus x upon 3. Then is equal to the 140 T, Z is the 603.19, 430 minus 141.63 divided by 3 is equal to the 30.05 into 10 raised to 6 Newton per mm is equal to the, this Newton per mm convert into the kilonewton per meter is the 30.05 kilonewton per meter. Then step number 5th, step 5, shape uniformly distributed load. Shape uniformly distributed load. Mr is equal to the Bm is the 30.05 is equal to the WL square by 8 is equal to W into 4 square by 8. Total UDL W 15.025 kilonewton per meter. Assume effective cover effective cover 30 mm. Then therefore D is equal to the 430 plus 30 is the 460 mm. Self weight of beam W is equal to the gamma BD is equal to 25 0.23 into 0.46, then is equal to the 2.645 kilonewton per mm. Therefore safe UDL is equal to the total UDL minus self weight is the 12.38 kilonewton per meter. This problem is over. Then again explain this problem one by one. A reinforced concrete beam section of size 230 mm wide and 430 effective depth is reinforced with 3 numbers of 916 mm diameter bars. Find the moment of resistance of section using WSM approach. Also find safe intensity of uniformly distributed load that can be placed on simply supported beam of effective span 4 meter. Use M20 grade of concrete and Fe 250 steel. In this problem, solution is given data: width is 230 mm, effective depth D is the 430 mm, then reinforcement is the 3 by 16 mm, effective span L is the 4 meter, then M20 and Fe 250 sigma CBC is the 7 Newton per mm square, and sigma ST is the 140 Newton per mm square. To find safe UDL WSM, modular ratio M is the 280 divided by 3 into sigma CBC is the 280 divided by 3 into 7 is the modular ratio is the 13.33. Then the area of steel in tension AST is the N into pi by 4 D square. N is the 3, pi by 4 into D is the 16 square. Then step number first is the critical depth of neutral axis XC. XC is equal to the 1 upon 1 plus sigma ST upon M into sigma CBC into the D. Then put the values. The answer is the 172 mm. Then step number second is the then thank you.